dear students, how are you all? A hearty and warm welcome as usual to all of you to Classroom TV. You can also visit our official website, which is classroomtv.in. So, in previous class we had seen how we are looking now into transmission. Before we had seen about reflection, now we are looking into transmission, transparent surfaces. Before that we were looking into opaque, highly reflective, shiny surfaces. Now we are looking into transparent surfaces, transparent, transmission, transparent surfaces and transmission we are looking at. And how transmission, in that whenever light gets transmitted, there is one special case will be there in which when the light ray is obliquely incident. Obliquely incident means what? It is not normally incident, it is making some angle with normal. Such a light ray at the surface separating the two transparent medium like air and water, there it will bend. And this bending is the cause of the bending also we found out. What causes this refraction? Refraction is what? Deviation of the light ray as it enters another transparent medium. It has deviated. This is called deviation. Again here it should have gone like this, but it has deviated. It has bent. That is called as refraction. And what is the cause of refraction? What causes refraction? It is the change in the speed that we were discussing. The change in the speed of light or change in the velocity of light, change in speed of light causes the bending, and since the change takes place only at the interface and other time the speed remains constant, the velocity of light otherwise remains constant as long as it is travelling in the water. It changes only when it enters water from air, or it is entering glass, or it is getting transmitted to the glass from water. At the interface only the change happens, the velocity changes once and afterwards it remains constant, and at that very instant, at the very instant when the velocity changes, the light ray also bends. There is a change in velocity. So, velocity of light in air and velocity of light in water, of light in glass, they change, and because of that there is bending is happening. And we are also noticing some pattern here. As the velocity decreases, it is bending in one particular way, and as the velocity increases, it is bending in exactly opposite way. So, this is the cause of refraction, change in the speed of the light as it enters, at the very moment it enters the interface. So, and we have also given name. The ray, already we know any ray which strikes the surface. Here we are talking about transparent surface. Any ray which strikes the surface is incident ray, and then the ray, this is refraction which is happening. Therefore, the another ray we will call as a refracted ray. And as you can see here, it is travelling fast and it is slowing down, and then again as it enters air, it is resuming its normal velocity. Again have a good look, as long as it is travelling in air, speed is constant, then again in glass also its speed is constant, but at this moment the velocity is changing. The speed of light or velocity of light is changing at the interface only, otherwise inside the glass it is constant and outside the glass also it is constant. Only at the interface it is changing, and therefore, instead of going in this direction, it is deviating. It is deviating, and you can see we have drawn normal and the velocity is decreasing. One pattern is there, that pattern we will discuss in detail later on, but this is about refraction, the cause of the refraction, where the refraction takes place. Now, so the cause of the refraction is the change in the speed or velocity of the light, change in velocity of light or speed of light in different medium as light enters different medium. But now the next logical question should be, why does the speed change? Means what is that particular property of the medium which changes the speed of the light? What particular property? Why does the speed change? We already know why speed changes, why velocity changes. We are using the word speed and velocity interchangeably, that does not matter. Light travels in straight line, therefore speed and velocity, they are same. So, why speed changes? Which property of the medium, causes the change in the speed of the light? So, that property of the medium is called as optical density. The property of the medium which causes the change in the speed of light is called optical density. And optical density, a property of transparent medium. Remember, it is not a property of opaque medium, because in opaque medium light cannot travel at all. Translucent medium also does not properly allow all the light to be transmitted through it. Therefore, optical density is a property of transparent material or medium, transparent material or transparent medium, such that is inverse measure of the speed of the light through a material. Inverse measure means what? Optical density tells us, if more is the optical density, the speed of the light will be less. That is the meaning of that, inverse measure of the speed of the light. Less is the optical density is less, the speed of the light will be more in that medium. Now, optical density is different from normal density. Normal density which we talk about is mass by volume, that is material density, that is mass density. This density is a different property. Now, we are talking about optical density. We are not referring to this density, mass by volume. Remember, there are many substances who have optical density higher, but normal density is less, and vice versa also. So, we are talking about optical density here, and it is not same as mass density. It is different from mass density. It is a particular property which we do not want to discuss in great detail, but what it allows, whenever light enters any material medium, light travels in the form of photons. Now, these are all new terms. The energy of the photons is absorbed by the electrons of that material, and then these electrons re-emit that energy to, in this way the transmission of light takes place. The time difference between that electrons taking energy from photons, photons will give their energy to electrons, and then electrons will keep on passing it. So, that time delay, that is the optical density, and that is what which causes, we do not want to go and discuss with that, but just remember, optical density is not same as this mass density, mass by volume, these two are different things. This is a optical property of the medium related with light. Optical density is a optical property. Optical density is a optical property, not a normal physical property. And optical density increases, velocity decreases. If the optical density will increase, then velocity of the light, speed of the light, this implies that speed of the light will decrease. Optical density increases, optical density, we are talking about optical density. If the optical density increases, then the speed of the light decreases. So, now again have a, what causes refraction? Refraction is caused by change in, refraction is caused by change in velocity, change in speed. It can be increase or decrease also. And what causes change in speed? Optical density. So, what causes refraction then? By default, what causes refraction? So, refraction is caused by the optical density of different transparent medium. As light travels from one transparent medium to another transparent medium, then the optical density will change, the velocity will change, and there will be bend. Light will bend at the very moment where the change is happening. So, the determining factor here is optical density. What is the determining factor? Optical density is the determining factor, and therefore, optical density determines the bending of the ray of light. What does optical density do? Optical density will determine how much bending is taking place. Light ray bends, how much it is bending. Now, different optical mediums will have different optical densities, and therefore, the amount of bending will be different, and therefore, it determines the angle of refraction also. The angle of refraction is what? Angle which the refracted ray makes with normal. As the refracted ray, this is the medium and this is the normal, light ray is travelling, and instead of going, it is travelling like this. So, this is the normal here, and this angle is angle of refraction. This we are going to study in detail, but the theme here in reflection as well as refraction, all the angles are measured with respect to normal. So, using logic, you can easily say what is the angle of refraction? The refracted ray makes with normal. What is angle of incidence? The angle which incident ray makes with normal. What is angle of reflection? The reflected ray, the angle which reflected ray makes with normal. So, therefore, the amount of bending determines the amount of the angle of refraction, and all these things are determined by the optical density. Now, how to measure optical density? But before that, remember, medium is said to be optically denser if it slows down, if light slows down in it. Speed of light decreases means what? Light has entered optically dense medium. Light has entered optically dense medium means its speed has decreased, and if the speed of light increases upon entering a transparent medium, light has entered a transparent medium, this is normal, and its speed increases. Then V2 greater than V1, this means what? It is optically rarer medium. On the other hand, if V2 is less than V1, then it is optically denser medium. If the velocity in the second medium is less than in the first medium, and the second medium is optically denser with respect to the first medium. So, we are talking about optical density and we are comparing it. We have to compare it, and we also, why we are comparing? First, you understand optically denser means light slows down, optically rarer means light speeds up. Now, optical density we have to compare with respect to these two mediums. They are as important as optical density is. It is also significant that we have to compare the densities, means what is the optical density of the second medium with respect to first and vice versa, because that will determine the direction in which light ray bends. That also, so everywhere the direction of bending, the amount of bending, optical density will control everything. As we have seen here, in this case, when light is travelling and speed is decreasing, light ray is bending in one particular direction. On the other hand, when its velocity is increasing, it is bending in opposite direction. So, everything, the amount of bending, the direction of bending is controlled by optical density. And how do we know? We have to compare the optical densities of these two medium, like in which direction the ray of light will bend when it travels from air and water. So, what you will have to do? You will have to compare the optical density of water with respect to air. Now, here the ray of light is traveling from water and entering glass. At that time, what you would be doing? You would be comparing the optical density of glass with respect to that of water. Glass and water here are the two players. Now, when it is traveling from glass to air, then you have to compare the optical densities of glass with air. So, as the two mediums will change, the optical densities, the here water and air, different thing is happening, water and glass, different things are happening. So, we have to compare the optical densities of the mediums which are involved there. And this comparison gives rise to the measure. How to measure the optical density then? That is the question. Now, see, light in vacuum has a maximum velocity. Velocity of light in vacuum is maximum. We know that velocity of light in vacuum is 3 into 10 to power of 8 meter per second. And when it enters glass, its velocity decreases considerably. That is because of optical density. So, if light is like this wrestler or power lifter, then light behaves like a weak feeble person in glass. This decrease in the velocity of light is caused by optical density. Talking about optical density, then what is the measure of optical density? How do we measure optical density? Normally we will measure density as mass by volume, that we are not considering here. We do not want to consider this. This is not that mass density or volume density. We are talking about optical density. So, how to measure the optical density? So, there is a term called refractive index. This refractive index, please have a look at this word refractive index. It is a measure of optical density. How do you measure optical density? That, like we measure different physical quantities differently, in the same way optical density, its measure is given by refractive index. Now, look at the term refractive index. It consists of term refractive, means something which is suggesting refraction, ability to refract. Refractive is what? Ability to refract. It is a common English like refraction. If it is a noun, then what will be refractive? Refractive will be adjective or something. So, refractive means what? Ability to refract, and index means what? Indication. By how much refraction, what is the ability to refract? Indication of that, that is called as refractive index, and it is a measure of optical density. So, now we will shift our attention now from optical density to refractive index, and it is very important concept in refraction. You should understand carefully the concept of optical density, concept of refractive index, how they are interrelated and what is the subtle differences, how refractive index measures optical density. All these concepts have to be understood carefully. So, refractive index, definition of refractive index, the indicator of the optical density, the indicator of the optical density of the material. Simple definition is indicator. Now, how does it indicate? That is the question now. It indicates whether the optical density is high or optical density is low. But how does exactly it indicates? That is the question. So, it is a number which indicates the number of times slower the light wave would be in that material as in it. Means what it is doing is that refractive index is comparing, refractive index is comparing velocities. Refractive index is doing what? It is comparing velocities or speeds. With what it is comparing? Velocity of what? Velocity of light into different mediums. It is comparing that. And what standard should be there then? For comparison, there should be one fixed standard should be there. So, therefore, what refractive index does is that it compares the velocity of light in any given medium, in any given transparent medium. Any given transparent medium is there. Its velocity or its speed is compared with vacuum. Speed is compared with vacuum. That is done by refractive index. Now, we know that the speed of light is maximum in vacuum and it is less in all other medium. So, that means what it is doing, the comparison will be what? It will be simple comparison by how much the velocity is less, because the velocity of light is maximum in vacuum. So, Vmax maximum velocity of light which is possible is velocity of light in vacuum, which is denoted by c, and it is 3 into 10 to power of 8 meter per second, which we know already. And in all other transparent medium, the velocity will be less. Velocity in medium 1, velocity in medium 2, velocity in medium 3, velocity in any nth medium will be always less than c. Then by how much it is less than c, that is given by refractive index. Now, if suppose the velocity of light decreases considerably in some medium, so Vm is much less than c. That means light is slowing down considerably in that medium. So, this means what? The ratio of c by Vm will be high, quite high. This ratio will be high, and that numerical value is refractive index, and that is also the optical density of that medium with respect to vacuum. In this way, refractive index, by comparing the velocity of a given medium with respect to vacuum, comes at some number, and that number is the refractive index of that medium, and it is also the optical density of that medium. In this way, refractive index helps us to measure the optical density. Now, here we have three medium: air, water and glass, and we are considering C. As we were discussing that optical density is the most crucial part of refraction, and refractive index is a measure of optical density. How optical density is most crucial? Because optical density of different mediums determine the bending, the direction of bending and the amount of bending. So, see here air, water and glass. So, the velocity in glass is here in these three mediums, optical density of glass is maximum. So, optical density of water greater than air and of glass is greater than water. Now, so when the light ray travels from air to water, light ray is traveling from air to water. At that time, air to water it is traveling obliquely, not normally, not vertical. So, its velocity is going to decrease. We have said optically denser medium means speed of the light is less. So, here velocity of light has decreased now, and how it is bending? Ray should have travelled like this, but now it is travelling towards the normal it is going. Here again now optical density of glass is higher than that of water. Now we are comparing again two different mediums and it is bending. Now what we have done is now incident ray is travelling from glass to water and then to air. So you can see here the angles are decreasing, the angles of refraction they are decreasing, angles of refraction they are decreasing when light ray travels from optically rarer medium. So the less density we will call them as less optical density, that is rarer medium, and high optical density that will be denser medium. So when in context of refraction, if we are talking about rarer medium and denser medium, we are talking about optically rarer medium and optically denser medium. And water is optically denser than air. What is its significance? Velocity of water is less than velocity of light in water is less than velocity of light in air. And now glass is optically denser than water. What is the meaning of that? What is the significance of that? Velocity of light in glass is less than velocity of light in water. And this will also mean that the velocity of light in glass is much less than velocity of light in air. And what is happening now? See, angles of refraction are decreasing. You will also find that R1 is greater than R2 or R2 is less than. Angles of refraction are also decreasing considerably. R2 less than R1. Now this will also depend upon these two angles, angle of incidence and angle of refraction will depend upon angle of incidence also. But in optically denser medium, angle of refraction will be less. Velocity is less and angle of refraction is also less. That is all decided by optical density. Now what we have done is we are transmitting light from denser medium to rarer medium. This is denser, optically denser, this is rarer and this is more rarer, less. Now compared these two, we are comparing these two. And when we are comparing these two, this is denser and this is rarer. So that means, it also means that one medium can be optically denser than another medium and it can be optically rarer than some other medium. So it will cause lots of confusion. How to say which is optically denser? Water is denser than air and glass is denser than water. Then something might be more denser than glass. At that time it will create lots of confusion. So what we do is that we compare all the transparent medium with respect to vacuum. Standard reference, vacuum or air. We compare the optical densities of all the medium with vacuum, so that there is no confusion at all. Now glass is more denser than water with respect to vacuum. So glass optical density or refractive index will be much more than water. So in this way there are two ways now we can compare the two different media with respect to each other. At that time there is no limit. You can replace water by any other transparent medium, you can replace glass by any other transparent medium, and that comparison will be different than the comparison between glass and water. But you can compare all the medium with vacuum also. When we compare all the medium with vacuum, then we will automatically know which is more denser than other transparent medium. So two ways here, compare with respect to each other and compare with respect to vacuum. And now here again you can see angle bending is different from this, what happening here, and velocity is increasing. So what we get, velocity same, velocity of water will be greater than glass, and velocity of air greater than velocity in water. And also you will find that angle of refraction is also increasing. So, if the refraction is taking place in optically rarer medium, then angle of refraction will be large, and if the refraction is taking place in denser medium, then the angle of refraction will also be less. So, this optically denser glass is optically dense, means what? The velocity of light in glass is minimum compared to all. So, in vacuum it is 3, in air approximately same as that of vacuum, and water and glass. So, we were saying that glass is the optically densest amongst all of them. Glass has the highest optical density. So, translated, what it means, that the velocity of light is very less in glass compared to that in water. Water has more, velocity of light in water is much greater, which is 2.25 into 10 to power of 8, and in glass it is 2 into 10 to power of 8. So, this means velocity is decreasing, but optical density is increasing. Optical density, velocity decreases and optical density is increasing, and glass has maximum optical density. So, optical density, velocity and optical density are inversely related. Now, therefore, now amongst all this air, water and glass, glass will have higher refractive index than water, because the optical density of glass is maximum. Now, this we want to prove that glass has more refractive index than that of water and that of air. So, how would we do that? So, refractive index is a measure of optical density, and refractive index, what does refractive index does? It takes the ratio of the two velocities. Now, there are, as I said, it can be like light travelling from glass to water or water to glass, that would be comparison between these two, but we do not want to indulge in that. What we want is that we will compare all the material medium, transparent medium with respect to vacuum. So, if you want to find out refractive index of glass, you want to find out refractive index of glass with respect to vacuum. At that time, it will be called as, so here what we will do, we will just take the ratio of the two velocities. So, 3 into 10 to power of 8 meter per second is the velocity of light in vacuum, and 2 into 10 to power of 8 is the velocity of light in glass. So, what does the refractive index of glass comes out to be? It is 1.5, and look what it means, that refractive index is 1.5, it is a measure of optical density. And what is the meaning? How do you read this? You will read this as refractive index of glass is 1.5, it means that the velocity of light is 1.5 times slower in glass than in vacuum. How slow the velocity becomes in a given medium is given by refractive index. Now, if we want to find out refractive index of water, then for water what it will be? 3 into 10 to power of 8 divided by 2.25 into 10 to power of 8, and this comes out to be 1.333. So, refractive index of water is 1.333, means what? The velocity of light in water is 1.333 times less than the velocity of light in vacuum. how much the velocity is less, how much the velocity is slower, it tells that number. So, and refractive index, symbol of refractive index is nu. Some books it is given like this, pronounced as nu, and some books it is given as mu. So, we will be using interchangeably. Different boards across India are using different symbols, and both the symbols are equally valid. They can be used, they are internationally accepted symbols. So, symbol is mu, refractive index, and it is a measure of. So, again recapping about refractive index is a measure of optical density of the transparent medium. It measures optical density. And it tells us by how much the velocity of light has decreased in the given medium, and its symbol is this. So, therefore, we can then write down, we can see here, instead of saying it is travelling from rarer denser, we can also represent the refraction in this way. Air refractive index is 1. Why refractive index of air is 1? Because velocity of light in vacuum and air is same, both are same. So, the ratio will be what? What will be the ratio? C divided by velocity of light in air is 3 into 10 power 8 divided by 3 into 10 power of 8, which is equal to 1, because velocity of light in air is same as velocity of light in vacuum almost. Actually, it is 2.94, not 3, but there is not much difference. So, therefore, we write as 1. So, what is the refractive index of air then? 1. Already we found refractive index of water, which is 1.33. Then air and glass, refractive index of glass is 1.5, and diamond refractive index is 2.4. Means what? The velocity of light in diamond is 2.4 times less than velocity of light in vacuum. And now compare the differences now, the difference in the refractive indices. This is 1, this is 1.3, this is 1, this is 1.5, and 1 and 2.4. So, the differences in the refractive indices is also large when the optical density of the medium is high. Diamond has very high optical density. So, its refractive index with respect to air will be high, and therefore, you can see the bending, amount of bending here. Air and water, same angles of incidence we are taking same angle of incidence here, I1, I2 and I3, such that I1 equal to I2 equal to I3. For same angle of incidence, the bending is maximum in diamond, because its refractive index is very high. So, refractive index indicates the refracting ability. What does refractive index indicates? Refracting ability. It indicates the refracting ability of given transparent material. But you should remember that this ability, this refractive ability depends upon the first medium also, like the light rays travelling, and this is the normal which we have drawn, this is angle of incident ray, angle of incidence, and the refraction is taking place in second medium. So, the refraction will not just depend upon its refractive ability, it will depend upon the first medium also. So, suppose here there is air and here we have glass, but instead of air, suppose we have water here, then the refractive ability of glass will be different than in this case. So, suppose air and glass combination is there and we have water and glass combination. So, same second medium which is the refracting medium where the ray of light is bending. The ray of light is bending always in the second medium. Incident ray travels in first medium. Remember, now you will say light ray can travel in this direction in any which way direction. So, first medium and second medium, if there is any confusion, wherever the incident ray is there, that medium is first medium, and of course, the other medium will be the medium in which refraction is taking place or refractive medium. So, always first of all this is incident ray. So, this is incident ray, therefore, this is incident medium or first medium. So, it will be called as incident medium or first medium, and then logically refraction is taking place in second medium. So, this is called as refracting medium or second medium. We use the term 1, 2 because 1 can be any and 2 can be any. Now, the ability to bend is we are finding for refractive medium, not for the incident medium. So, the bending ability will not just depend upon the second medium, it will also depend upon with what it is paired up. So, glass is now paired up with air and glass is now paired with water. So, the bending which will take place in both the cases will be different. Here let us draw this again. And instead of going straight, it is going in this direction, and here again same angle of incidence and it is bending more. We cannot right now say where it will bend more or less, that we will have to solve, but the thing is that for same angle of incidence I, the bending done by glass is different in these two cases. So, therefore, we find out two abilities, refractive index with respect to vacuum and then refractive index with respect to whatever might be the first medium. Like in this case here with glass we will find out refractive index with vacuum or air, refractive index of glass with respect to vacuum or air, that we will find out, and then as the situation arises whatever is the first medium, then refractive index of glass with respect to that medium, relative. So, this is called as, whenever we find refractive index with respect to vacuum of any given medium, that will be called as absolute refractive index, and when we find it with respect to any other medium, that will be called as relative. Now, here just check out the refractive index now. These are the absolute refractive indexes we are talking about. So, vacuum, what is the absolute refractive index of vacuum with respect to vacuum itself? It will be 1. Then we have water which we have found out, and glass 1.5. Now, this distinction between absolute refractive index and relative refractive index we will see in more detail in our next class. It is really very interesting, but you have to be careful, there is subtle difference here. We are talking about refractive index itself, it is done by the second medium, but it also depends upon the first medium. If the first medium changes, then even though the second medium has not changed, the refraction is changing, and therefore, in order to avoid this confusion, we do the comparison of all the transparent medium with respect to vacuum, and then we can compare individually any two mediums. So, all this we will discuss in our next class. Till then, goodbye to all of you.